Yes, dear student, actually last video, I was telling last video the diffraction due to single slit, and I derived the formula for angular spread theta equal to lambda by A. And I told you that when lambda 6000 angstrom and A 0.001 millimeter, then angular spread was nearly 30 degree. So I am continuing here the remaining part of that topic. So here I told you, okay, here was the slit, it was the point O and P there. This also. So we get here intensity maximum and then decreasing. Along with the maximum light produced at O is called central maximum. At O, whose intensity decreases gradually around O and becomes zero at P. Now, along with central maximum, there occur secondary maxima or subsidiary maxima also, whose intensity is very low. Along with central maximum, there occur subsidiary or secondary maxima also, whose intensity and width is much smaller than central maximum. This thing is also very important to learn. Now, if we plot graph, we said this angle theta, lambda by d, angular portion. So we get minimum at condition theta equal to plus minus n lambda by a. Minimum, maximum ka, then we get maximum also if I plot the graph between intensity of secondary maxima along with central maximum. Actually here it is lambda by a, 2 lambda by a, 3 lambda by a, 4 lambda by a, minus lambda by a, minus lambda by 2 lambda by a, minus 3 lambda by a. That is from this condition and so on. So central maximum has intensity this height in represent intensity. Don't think that some tower is there. This represents this much intensity, unit of intensity. Then it becomes 0 here at lambda by A, and then we get secondary maximum like this and like this. The intensity keep on decreasing and finally becomes 0. And if we join the heads, we get this variation like this. So here these are secondary maximum. By at theta equal to 0, we get maximum. Now where the secondary maximum by intensity becomes 0 at theta n equal to plus minus n lambda by A, 0 intensity. Now for maximum angular position of secondary maximum. Whose intensity are very low. That theta n equal to 2n plus 1 lambda by 2 plus minus. Here n equal to 1, 2, 3, 4, not 0. But remember, this represents the intensity, the large intensity, much brighter, and secondary maximum have low brightness. Actually, this thing can be practically observed in one experiment. If we have here a lamp, chimney of lamp, here is a lamp producing light, this chimney, and we cover this chimney with the black polythene and then make cut by a narrow. We make a cut in the polythene, a narrow cut by a razor. Then we find some light coming out from this. If we take the photograph of that light and make enlarge that, then you get this is central white. This is bright, dark, and these are central white. Then again this bright. So width of the bright keep on decreasing and finally whole thing become dark there. So many bright lines are seen in the photograph. मैं समझा रहा हूँ कि ये बल्ब है. And we wrap here a polythene and make a narrow cut by a razor. The light comes out of this. If we take photograph, we get many white bright. The central bright will be wider than other. The width keep on decreasing, intensity keep on increasing. So this width here is given by this, and intensity maximum. The angular position of secondary maxima is given by this, and minimum intensity is given by this. Many questions you will get numericals. Actually, in board exam we get numerical on this. Now why we are studying this when it is so it is observed so with difficulties? Actually, dear student, you know, every solid material has this atomic distance between them. जो हमारे solid material हैं, उनके atoms की distance is there, but we are not able to see the distance between molecules. Our naked eye, not only naked eye, but even optical microscope cannot see the gap between two atoms. Why it is so? Why it is so? So here wave nature of light. Light shows diffraction, and due to diffraction, the image form of object, point object, by a lens. Suppose it is lens here, it is point object. Then the image here formed by this will have an angular spread having angular radius lambda. Theta equal to lambda by radius. Or you can find out, this is one thing more, we can find out linear distance also. If it is this theta, this distance is z, this is y. If theta is small, then theta equal to tan theta equal to y upon z. But theta also equal to lambda by a. But theta equal to lambda by a. So lambda upon a equal to y by z. So y equal to lambda z upon a. So larger the distance, wider is the linear spread. Theta is the angular spread. With the help of theta, we can tell how much it is, y this way and y this way. तो टोटल जो लीनियर स्प्रेड होगा, लीनियर स्प्रेड अराउंड O will be 2 lambda z upon a. Z, what is z? Distance of the screen from the slit. So due to this angular spread, the image is not a sharp image. I am telling what is the problem with diffraction of light. It is point object here or narrow slit, whatsoever may be. If we get the image of this object by this lens, then due to this size, there will be angular spread theta equal to lambda by a. A is the diameter of the aperture. Or smaller the aperture, greater the theta. So the image of point object will not be a sharp image. It will be an angular disc having angular spread this. And therefore, if 2 points are placed very close to each other, then their central maximum may overlap each other, and the two objects appear as one, and we cannot see the images of closely placed objects separately. Have you got my point? Due to wave character, light shows diffraction. I will tell you in next video the term which I am going to define. Due to wave character, light shows diffraction. Due to diffraction, the image formed by object, any lens or point object will not be a sharp image. It will be having angular spread theta equal to lambda by a. So if there are 2 points very close to each other like this here, then their central maximum may overlap and they will appear as one, and we are unable to see them separately. This is called the limit of resolution. Every optical instrument has ability to show the separate images, and that ability of optical instrument to form separate images is called resolving power. I will define and tell you the reason. I have explained why there is limit of resolution, because of diffraction. So diffraction of light causes this trouble, and when distance between two objects become very small, we can't see that distance, means we cannot resolve that. I hope you have got my point, and more it will be clear. It will be more clear to you when I will be doing numericals for you. There is one more topic here. Validity of ray optics. Yes, I can do here. Validity of ray optics. What is that? Up to what distance light is supposed to travel straight? So here I told you that theta is equal to lambda by A. And if this y is a linear spread, then theta is equal to y by z also. If y is equal to A, means the angular spread is equal to width, then light is supposed to travel straight. But if this, that will depend on this distance z also, and therefore theta will be here A upon z. Comparing the two equations we get A upon z is equal to lambda by A, and hence z is equal to A square upon lambda. Up to this distance z, which is determined by size and wavelength, we can think that light can travel straight. But light always travels straight, but because of diffraction it bends around the corner. Up to what distance we can suppose that light travels straight? So because of this nature. Now you might have heard a topic, radar. Full form of radar is radio detection and ranging. Radio detection and ranging. In warfare, we see the movement of enemy aeroplanes. In navigation, in the sky, aeroplane remain connected to the airport from which it starts its journey. The radio wave are electromagnetic wave, I have told you, which are used for communication. And in those radio waves there is a sort of wave, microwave. I have told you microwave are the radio wave of shortest wavelength. Shortest wavelength. Radio waves. Radio waves are called microwaves. Microwaves. So microwave are used in radar. Why? Because by radar we want to find out straight distance of the object in the sky, like aeroplane. And microwave being shortest radio wave have small angular spread because of smallest wavelength. Their wavelength vary from fraction of millimeter to 10 or 15 centimeter only. Other radio wave have wavelength of certain 100 meter, 200 meter, 500 meter, varies from 10 meter to and so on. So longer the wavelength, greater the spread. So you can answer कि क्वेश्चन पूछते हैं वो why do we use short microwave radar? Because microwave can travel a long distance without significant bending. So we can find out we can check the direct distance of the object in the sky moving towards us, or that give Doppler effect also, Doppler effect. We can tell, we can detect the distance as well as speed of the object. We can tell using radio radar that whether the object going away from us or coming to us. But we use microwave there because of short wavelength they can travel straight a long distance. As I told you, Z is equal to Z is the distance up to which light suppose travel straight. So I hope you will enjoy and read and watch it repeatedly, not and read the book also. Before making your this whole lesson, though I had a very long experience, but I read again many books, 2 or 3 books here with me, and then I started telling you the things. And in coming videos, I will be telling you the numerical portion of this chapter. Thank you.